WPI's Student Government Association, also known as SGA, is responsible for funding all clubs on campus. However, that is not an easy task. One of their main issues is to decide how to evenly distribute the annual budget. Many clubs have questioned if the process is fair enough. Another issue is that SGA may sometimes exceed its annual budget. Considering that, the objective of this project is to develop a model to be fair and practical, distributing the annual budget among the clubs.
So before we could begin to solve our problem, we had to come up with a list of all of our assumptions. The first assumption we had was that we're only going to look at the annual budgets of clubs and not looking at any funding requests that they might submit throughout the year. The second assumption was we're not going to evaluate any of the club classes 4, 5, and 6, which are clubs that have selective membership or are part of Greek life or provisional, because they all have their own finances separate from SGA. Then we decided that the budgets that the clubs ask for have been approved by SGA in the past, so the club can ask for the same amount they had last year, and in theory they should be all set in doing so. We also said that SGA would have no bias or favoritism given to any club based on any members within SGA being in any other clubs on campus. We also said that SGA distributed their budgets evenly in the previous year, so each club can ask for the same amount they asked for last year, and that would also work out okay. We said, based on our client's information, that $1 million is the total budget that SGA has in order to distribute to all of the clubs. And in our model, all of the clubs who asked for budgets were already approved to receive budgets, so they should all get some amount of money for the most part. We said also that if clubs received money last year, they will still need that money this year in order to function. And sort of building on that, clubs can receive up to 20% more than whatever it was they received last year, but in order to not cut funding too much, we said SGA will approve at least 20% of what the club asks for, because some of that will be stuff that they need.
In our LP, there will be 4 constraints. The first constraint will be the summation of all the clubs in all the classes being equal to or less than the max budget, which will be $1 million. In our 3 constraints, for each class, there'll be the summation of the clubs related to those classes being equal to or less than a distribution of the max budget. We do not want any of the clubs to have a monetary amount of 0, so we will be setting up a upper and lower bound. The lower bound being 1/5 of what they requested for last year, and the upper bound being what they received last year plus a 20% more.
So now our team has come up with a prototype model that we coded with MATLAB and using a building function called LinProg. LinProg is designed for minimization problem. Since our problem is maximization, so we're inverting the signs of the coefficients in the objective functions. That means we have 62 variables with -1. Now, we have to set up our constraints. Constraint 1 will be the maximum budget that SGA could distribute to all the clubs on campus. Constraint 2 will be the amount of money that Class 1 gets. And then constraint 3 would be the amount of money that Class 2 gets. And then constraint 4 would be the amount of money that Class 3 gets. Now, we have to assign all of this money into variables, and we store them in constraint 1, constraint 2, constraint 3, and constraint 4. In the end, we put them into our model. So for our lower bound and upper bound, we also need to set them up. For our lower bound, it's actually 0.2% times the budget that each club gets last year. And our upper bound will be 1.2 times the amount of budgets that clubs applied for last year. So we're assuming that the clubs will at least get 20% of what they asked for. And it's also possible that they may apply for more budgets this year compared to last year. Now we are ready to compute our results. Since it is a maximization problem and LinProg only supports minimization, we have to take the absolute value of the results, otherwise the results will be negative. Now, our results are showing below. As you can see the results, they are pretty reasonable comparing to the amount of budgets that each club got last year. When you look at the sum of annual budgets, that's approximately about $610,000, which also makes sense since we're only putting approximately half of the amount of clubs on campus.
Now that our model was created, we have a few suggestions. First, SGA should introduce all the clubs' budgets as variables in our model, in order to make our LP more tangible with the real problem. Second, SGA should develop binary variables for all the events that clubs can add to their budget. Our current model assumes that the budget analyzed fits the SGA bylaws. However, that's not always the case. By adding the binary variables, our model would serve as a filter for invalid events, eliminating one of the steps on SGA's process. Overall, our prototype achieved its goals. The LinProg used in MATLAB produces a reasonable, feasible, and optimal solution. Besides that, the model can have a big impact on the current SGA process, satisfying the whole student body. Our model can also be adapted to different situations, for example, in a larger university with different bylaws. We hope that we can help SGA with this problem. Thank you so much for your attention.